Okay guys, our last review day we're going to be focusing on working with polynomials and just reviewing all the things we can do with those. Number one is we're going to be adding two polynomials together. To do that, you basically combine like terms. Like terms are two terms that have the same variable and exponent, kind of like that 2x squared and that 7x squared there. You can combine those by adding their coefficients together. So 2 and 7 makes 9, and we keep the variable and exponent the same. And we just kind of keep doing that. So we have 7x is like the 6x, and if we combine those, we get 13x. And then finally, we have the 7x to the fourth, which doesn't have a term that's like it on the other side, so we'll just bring it down the way it is. And then on this other side, we also have a negative 3x cubed, which also has no like term, so it stays the same. Typically, when you write your final answers, you start by putting the term with the biggest answer in the front. The biggest exponent, I should say. Follow that down, so then we go to the third power, then the second power, and then that's it. So, there's our final answer there. That's adding polynomials. Let's take a look at number 3. Similar situation, but this time we're subtracting the polynomials, and when you're subtracting polynomials, the one that has the negative in front of it, you're going to distribute the negative into the parentheses. The first one will stay the same, but every sign in the second one will change. And then after that, you're just going to combine like terms like we did on the first problem. This time I'll start with the terms that have the greatest powers. So we have 6n to the fourth can be combined with 1n to the fourth to make 7n to the fourth. And then we'll do the cubes. We have 7n cubed and 8n cubed. Since the 7 is negative, though, we'll be subtracting. 8 take away 7 is 1. And we don't need to write the 1. And then finally, we have the two squares here. We have a positive 1 and a negative 7. When we combine those, we get negative 6. So there's that final answer. Let's do a similar situation here, but this time it's just more, right? So we have 3 polynomials instead of 2. Notice that the 2 on the end here both have negatives in the front, so we'll be distributing a negative for each of these sets. And that will change the signs in each one of those sets. And then we can just start combining like terms. I'll start with the terms that have the biggest power first. We have negative 4, negative 6, and negative 7, which is all put together negative 17, x to the fourth. The next biggest term that I see up there are squares. So we have a 3x squared and negative 8x squared. Combining those, we get negative 5x squared. The next biggest term is the 2x there, but it doesn't have anything to combine with, so we'll just bring it down. And then finally we have the constants, the ones that are just numbers without letters. Adding all those together, we get 12. Switching gears here into multiplication. Notice that there's nothing between the parentheses this time. That means we're multiplying. The way that I talked about multiplying in our class was using a box to do so. We have 2r minus 7 multiplied by 7r plus 6. We're going to multiply to fill in this box, and as you multiply to find this box, we're going to multiply the one above it and to the left of it. And as we do that, we multiply the coefficients, 7 and 2. So 7 times 2 is 14. And you add the exponents of the r's. So r1 and r1 makes r2 when you multiply. To get this box, we do the one above it, multiplied by the one to the left of it. It's going to be negative 49. And it's just going to be r to the first since the 7 on top didn't have an r to contribute. Next, we'll do this one. That would be the 6 and the 2r multiplied together to make 12r. And finally, this last box is the 7 and the 6 put together, which is negative 42. I'm going to take the answers in my box out now, and as I do that, I'm going to start with the biggest power, which is r squared. And then the other ones are the r's, but we can combine those because they are like terms. We're going to add them together. So when you add like terms, just like we talked on the first 3 problems today, you just combine the coefficients. Negative 49 added to 12 is going to be negative 37, and you keep the r the same in that case. And then also we have the 42 at the end, which has nothing to combine with. There's our final answer. Right, this is a similar situation, but this time we have, instead of a binomial times a binomial, we have a binomial times a trinomial. So in that case, we're going to need a bigger box to accommodate the trinomial. Trinomial, I'm going to put along the top because there's 3 spaces for it. The binomial I'll put down the side because there's 2 spaces for it. And then we just fill in the box like we did in the last problem. And I'm going to take the answers out, starting with the term with the biggest power. And then I'm going to go to the next biggest power, which is the squares. We're going to combine our like terms there, which is negative 52 in the next squared. Then we have the x terms. 30 take away 14 is 16. And then 35. And there's our final answer for that one. Number 11, we're going to be factoring now. This one says factor out the common factor. That's a GCF method. So what we're doing is we're looking for something that can divide out of all 3 of these terms. Now you have to look at 2 things. You have to look at the variables and you have to look at the coefficients. So first of all, the variables. This one has 5 x's, this one has 1 x, but this one doesn't have any x's to give. And since the last one doesn't have any x's to give, we won't be taking any x's out. But for the coefficients, 20, 10, and 70, all 3 of those can be divided by something. They can all be divided by 10. So I'm going to divide a 10 out. 20 divided by 10 is 2. 10 divided by 10 is 1, but we don't really need to write the 1. There's an x there. And then 70 divided by 10 is 7. And that would be the GCF method for factoring. Now, whenever there's 2 terms, a lot of times that's either going to be a GCF like we just did, or it's going to be another method called the difference of squares. Now, as I'm looking at this, I don't see any GCF. I can't take any r's out, and 25 and 16 don't have anything in common. But what I do notice is that this is a difference of 2 perfect squares. And that means it's a difference of squares problem. When you have a difference of squares problem, your answer is always going to come in the form of a plus and a minus like that. You take the square root of the first term to find the first term of each set. Take the square root of the last term to find the second number in each set. And that would be your factored results. This is a trinomial, so it's not a difference of squares. You should always look for a GCF, but once again, there is no GCF, so that only leaves one other thing. When you have 3 terms, the only thing you can do after you've looked for a GCF is the box method. Okay, so when you're doing the box method for factoring, you put the first term in the top left, you put the last term in the bottom right. And then you're looking for 2 numbers that multiply to make the top left, which would be 2m and m. And then you're also looking for 2 numbers that would multiply to make the negative 20. Let's say negative 4 and 5. Now, I could be right or I could be wrong. This is a guess and check process. Here's how we can decide if our guess was right. We fill in the box with multiplication. So 2 times negative 4 is going to be negative 8m. And then 5 times m is going to be 5m. If these 2 diagonals here add up to make this number, then we've done good. Negative 8 plus 5 does make negative 3, and so I've got the correct answer there. It is m minus 4 from the top and 2m plus 5 down the side. Now let's just say it didn't work out. I got lucky on my first try here, but if it doesn't work out, the first thing you'd want to do is try switching the 5 and the 4 around. If that doesn't work, try a different set of numbers, like maybe 2 and 10. And you just keep testing until you get the pair that correctly gives you these adding up to make the middle. This one has 4 terms, and the one with 4 terms, like the one with 3 terms, is also a box method, but it's a little bit different in that you still put the k cubed here and the 18 here, but the other 2 numbers just go in the boxes that are left over. And what's good about this one is there's really no guessing and checking. If you know how to find a GCF, you can get the right answer on your first try. So you look for what these have in common. They both have a k in common, so I would factor a k out of there. Then you look at what these have in common, and you factor that out. In this case, they could both be divided by 3. And then we do the same thing horizontally. Here I can take a k squared out of those 2, and here I can take a 6 out of those 2. In the end, we have our answer k plus 3 from the top, and k squared plus 6 from down the side there. Number 19, we're going to solve some equations by using factoring. So, step 1 is to look for a GCF, but there isn't one. Step 2, since there's 3 terms, we're going to go with the box method. Now, if you don't remember how to do the box method, I would have you look back at the previous problem where I did that. But for now, I'll just kind of work my way through it. Now, I'm going to be taking a guess here, so I'm not sure if I'm right. So let me see if this works out. 7 times 8 is 56. And then 4 times x is 4x. Now, there's no way that 4x and 56 is going to make 20. So my guess was bad. So the first thing I need to do is back up a little bit, and I'm going to try switching the 8 and the 4 around first. And let's see if that works. Is there any way that 8 and 28 can make 20? Yes, there is. That would happen if the 28 was negative here. So that means the 4 is negative. And by factoring it now, I've got x minus 4 from the top, and I have 7x plus 8 from down the side. But we're going to go further than we did last time when we factored, because they want us to solve for x. Now notice it's equal to 0. Since it's equal to 0, you're going to take each factor and set them equal to 0. And then you solve each of those little miniature equations. And there's my 2 answers. X equals 4 and x equals 8, negative 8/7. So factor, set each factor equal to 0, and solve. Last thing we'll look at here is long division. So when you're doing long division, the first thing you want to do is set your problem up for division. You do that by taking the polynomial that comes first and putting it inside of a bracket here, like this. And you put the one that's dividing out here. Now, long division, what you do is you look at the first term, and you ask yourself, how many times does that go into this first term? Now, a better way of thinking about it, perhaps, then, would be to think about what would you multiply that first term by to get the other first term. So what would I multiply x by to get x cubed? And the answer is x squared. After you get that, you distribute that term to both of those, and you put your answer underneath. So x squared times x is x cubed, and x squared times negative 5 is negative 5x squared. The next step in the process of division is to subtract what you just put down there, which changes the signs of those numbers. These cancel out. 1 and 5 make 6x squared as a remainder, and then you bring down the rest of the problem. And then you repeat the process. So now I'm asking myself, what would I multiply x by to get 6x squared? So x times what is 6x squared? Well, that would be 6x. Repeating the process from before, you're going to multiply that times both of these, and you put your answer at the bottom. So 6x times x is 6x squared. 6x times negative 5 is negative 30x. And then you're going to subtract once again, which changes the sign. These cancel out, and I'm left with negative 2x plus 9. Repeat one more time, I think we'll do it. Now we ask ourselves, what would I multiply x by to get negative 2x? And that would be negative 2. Distributing that to these two terms and then putting my answer underneath, I get negative 2x plus 10. Changing the signs, I get plus and negative there. These cancel. I'm out of space at the bottom here, but 9 take away 10 is negative 1. Now this is my remainder. I can't go any further. You know you're done whenever the power on this is greater than the power here, and since there is no power there, that's definitely the end of our problem there. So here's how you write your answer with these. The thing on top is your answer from division. And then this thing down here is your remainder. And you put your remainder over the thing you were dividing by, which is x minus 5. And that's long division. All right, so hopefully that was helpful, and we will see you guys next time. And then have a good one.